So the main focus of my group right now is to develop a new hadron transport approach based on the Boltzmann equation and hadronic degrees of freedom, which will eventually provide a baseline calculation where we can then figure out a phase transition if experimental observations deviate from our calculations. And this is interesting because this work is relevant for basically heavy ion collisions at all different beam energies. So at the very high energies from LHC and RIC, the hadronic rescattering dynamics is important for the late stages of the reaction. Whereas in low beam energies, it's covering the full reaction from beginning to the end. And in the intermediate region, we still have to figure out how much of the reaction is actually covered by hadronic dynamics and how much we need fluid dynamics or an actual QGP is produced in those reactions. Yeah, since the coupling of QCD always gets very high in the regions of interest, namely in the region where partons are transformed to hadrons, for example, it's lots of things that we don't really know from QCD because there's not so many things that one can really calculate by first principles nowadays. But so there, on the other hand, then we have effective descriptions and models, and these are then important to talk to really compare to experimental data. One of the main points or things of this conference is also to bring together these large experimental collaborations and the theorists, and then we can talk about our predictions in respect to the measurements, which is always very useful, but also there can be surprising experimental results that trigger a lot of theoretical development to understand those. And I think this interplay is what makes this community so interesting and actually helps to understand a lot more about how QCD actually behaves. Yeah, so in general, I would say that in the first morning when we had all these highlight talks with all the new experimental data, there's not really a specific result I can point to at this moment, but what I really found impressive was the amount of different systems that we have measured now at LHC and at RIC, that there are so many different systems, from small systems, PP, PA, deuteron gold to helium gold, but then also this intermediate size system at LHC with xenon that just came out, and then the lead and gold results that are there at different energies. And I think this plethora of detailed systematic results was what impressed me most at the moment, up to now and at this conference. And also the other fact that results get way more precise, and that also is always, people start quoting the level of precision in a much more detailed way than we are very used to when things were just qualitative a few years ago. So this is really nice to see this development towards a more precision physics and very systematic understanding of a lot of different observables.